All right, this is notes 4-5. Okay, on these guys, we want to make sure that we are circling our formula. First formula is finding our determinant. Make sure you underline the actual work part of the formula, which is A times D minus B times C. We notice that there is a pattern of the matrix. It's A, B, C, D. A times D would be going crossways from top to bottom, minus crossways from top to bottom. That gives us our determinant. Our determinant, and this is labeled matrix A, so this would be the determinant for A. Okay, so if I was going to do the same thing here, I want to find the determinant. It's multiplying crossways from top to bottom. 3 times negative 2 minus 5 times 1. 3 times negative 2 is negative 6, minus 5 times 1 would be negative 5. When we combine those, that is negative 11. So the determinant for number 1 is negative 11. For number 2, same thing. Going to multiply crossways, so that's negative 1 times negative 2 minus top to bottom 4 times negative 3. Negative 1 times negative 2 is a positive 2. Negative 4 times negative 3 is a positive 12. When combined, gives me 14. Determinant for this guy is 14. Okay, we're going to find out if these two are inverses. The question is this an inverse of this? So the only way to find out is to multiply it and see if it comes out with a certain pattern that we're looking for. So I multiply just like we've been doing, top row times first column. 1 times 11 is 11. Negative 5 times 2 is negative 10. Top row times second column. 1 times 5 is 5. Negative 5 times 1 is negative 5. Now the bottom row times the first column. Negative 2 times 11 is negative 22. 11 times 2 is a positive 22. Bottom row times the last column. Negative 2 times 5 is negative 10. 11 times 1 is 11. Cleaning it up, 11 minus 10 is 1. 5 minus 5 is 0. Negative 22 plus 22 is 0. Negative 10 plus 11 is 1. So we notice that our matrix has a pattern of 1s starting from the top left-hand corner, going down to the bottom right-hand corner. So 1s going diagonal, everything else is 0s. You notice the exact same thing if it was a 3 by 3, 1s from the top left-hand corner all the way diagonal, everything else is 0s. Okay, if that occurs, then that means that this is in fact an inverse of this guy. So this matrix is an inverse of that matrix because of this pattern. If this pattern is anything other than 1's diagonal and everything else 0s, then this one is not an inverse of the first one. Okay, moving on. The second formula is the inverse of matrix A. That's what the little negative 1 means. It means inverse. Is 1 over the determinant of A, which is what we just did, was finding the determinants where we multiply diagonal, subtract, multiply diagonal. Here's our new formula for the inside of our matrix. We shift our original matrix around to look like this. Okay, so here we go. First thing I want to do is find my determinant. So multiplying negative 9 times negative 3 minus 5 times 6. And that gives us a positive 27 minus 30, which is a negative 3. That's my determinant. Determinant goes underneath the 1 in the formula. So 1 over my determinant, which is negative 3. Now I'm going to rearrange this guy, which is in this order, A, B, C, D, to this order. So clearly I just switch my A and my D. So these two are going to switch. So negative 3, negative 9 go in the two corners. Then I do the opposite sign for B and opposite sign for C. My B and C don't switch places, but they switch signs. So this was a positive 5, so now it becomes a negative 5. That's a positive 6, so it becomes a negative 6. Okay, from there, I have a number touching parentheses or brackets in this case. So we are going to distribute, multiply, negative 1/3 times negative 3. That is a positive 1. Negative 1/3 times negative 5. We can leave it a fraction, just a reduced one, is a positive 5/3. Negative 1/3 times negative 6. That would be a positive 2. And negative 1/3 times negative 9 is a positive 3. So what we just found was this guy is the inverse of this guy. If I were to take this one and multiply it by this one, so multiply these two together, I would get what we got on the first page, which is a 1, 1, and the rest zeros. Okay, looking at our second one, number 6. On number 6, we find our determinant first. So that's 6 times 8 minus these two guys here, top times the bottom, negative 16 times negative 3. A minus makes a plus. 6 times 8 is 48. 16 times negative 3 is negative 48. 48 minus 48 is 0. If I were to go back and try to plug that determinant in to the formula, I can't. If I put 0 in here under the 1, that's 1 over 0. We know that does not exist. That is impossible. That would give us an error. Cannot ever have a 0 in the denominator, so this one has no inverse. And our final one, finding the determinant. 1 times 0 minus negative 2 times 3 equals, minus a minus make a plus. So we have 1 times 0 is 0, 2 times 3 is 6. Putting it back in to the formula. Same formula. Okay, we have 1 over 6. Rearrange our matrix, swapping out A and D, so 0 and 1. Changing the signs for B and C. So this will be a 2 because it was a negative 2. This will be a negative 3. Now we distribute. 1/6 times 0 is 0. 1/6 times 2 would be 2 over 6, which reduces to 1/3. 1/6 times negative 3 is a negative 3 over 6, which is 1/2. 1/6 times 1 is 1/6. The problems that we are going to do, this one here is the inverse of that. Multiply that by that, I would get that 1, 1, and the rest zeros. Problems you do on your homework are A4-5, numbers 1, 4, 5, 6, 8, and 9. This concludes notes for 4-5.